In this video, I want to quickly recap inverse variation. So our main two ways that we're going to see this are this form on the left, y equals k over x, and this form on the right, y times x equals k. These mean the exact same thing. All we did to get from the form on the left to the form on the right is multiply both sides of this lift equation by x. So a couple examples of each of these. Remember that k is just a number, it is a constant. X and y are our variables. So what we say is these top two are our forms. This is a form, this is a form. And when we see that in an actual example, instead of k, there will be some number. So for example, k could equal 3, and our equation would be y equals 3 over x. K could equal 8. K could equal any number. Sometimes we may even see this written as a multiplication. Don't let that fool you. What's really important is where these variables are. Notice that I have y equals 8 times 1 over x. This variable is still on the bottom, just like over here, just like this, just like this. This is different from direct variation where both the x would be on the top in direct variation on that right-hand side. On the right, similar examples, and we have x times y equals 3, x times y equals 8. Remember, xy, this just means multiplication, so it doesn't matter that this is written differently. We have yx, y times x on the top, xy on the lower two. Means the exact same thing. Moving on to think about this graphically, the graph of an inverse variation is going to look something like this. This is just an estimate. This is the general shape of that graph. If you really want to make sure that what you're looking at is an inverse variation, you're going to want to think about the equation x times y is equal to k. This is one of our forms, remember? And so you want to pick points on this graph and make sure that it's true that for each xy pair, that x times y is equal to some number. So let's just make an example that would be true. I'm not making these points perfect on this line, I'm just using this as an example. So for example, if this was the point 2, 2, and this was the point 4, 1, and maybe this is the point 1, 4. So these are all x, y pairs of values. So the first number in the pair is x, the second number in the pair is y. Notice if I multiply these, for each of these, 1 times 4 is equal to 4, 2 times 2 is equal to 4, 4 times 1 is equal to 4. So you can find points on this curve and make sure that it's true that for every pair, x times y is equal to our value k. So in this case it is. It has the right general shape, and this is true, so this is inverse variation, where the value of k is equal to 4. Finally, we can think about this from the perspective of a table. Again, you're going to want to use that same form to analyze this data. X times y is equal to k. So all we need to do is we need to go through, again, just like we did in the graph, take our x values, multiply by the y values, and if those all equal the same number, then it is inverse variation. So let's just run through and do these really quickly to make sure. So 1 times 8, so 1 times 8, I'm just going down the column right now. 1 times 8 is equal to 8. 2 times 4 is equal to 8. 4 times 2 is equal to 8. So is 16 times 1/2. I'm just going to write 0.5. And so is 32 times 1/4. So this shows us that for each xy pair, it is true that x times y is equal to the same number, and therefore this is inverse variation, and we have a k value that is equal to 8. Remember, we call that k value the constant of proportionality.